Okay, what we got, n is an integer. Prove algebraically that the sum of half n, n plus 1, and half n plus 1, n plus 2 is always a square number. Usually like the proof questions. First of all, I would expand the brackets. So what I've got here is a half n times by n plus 1 equals a half n squared plus a half n. Okay, that was easy. Multiply that by that and that by that. And then what I'm going to do is look at, I'm going to look at n plus 1, n plus 2. Remembering I'm going to halve it. N times n is n squared. N times 2 is 2n. 1 times n is 1n. 1 times 2 is 2. So what I've got is I've got n squared plus 3n plus 2. And I've got a half of that. Remember, it's half of all of it. So that, in fact, is a half n squared plus 3 over 2n plus 1. I know some of you will prefer that this thing here is 1.5n. We'll worry about that in a moment. So now it says prove that the sum of these. So I've got a half n squared plus a half n plus a half n squared plus 3 over 2n plus 1. So and that's the sum. So I've got a half and a half, so I've got n squared. I've got a half n plus 1.5 n basically, which is 2n. And then what I've got is I've got plus 1. Well, essentially what I need to do is just factorise this. So if I factorise this, what I'm looking for are two numbers that multiply together to make 1. They add together to make 2. And of course they are 1 and 1. So what I've got is n plus 1, n plus 1. And as they are both the same, this is n plus 1 squared. And this, of course, is always a square number. There we go. Nice.